Now, what good are bigrams and collocations, right? Well, we can start asking questions. Instead of getting the most frequent bigram, for example, we can get, for example, all the bigrams where strong is involved, for example, right? And we can ask for word counts, like, for example, what collocation is more common? Strong with the word support or strong with the word feelings? So what is more common, right? Or do we say, string with the word signal, for example, as opposed to strong signal, right? What goes well with powerful? Powerful man, powerful magnet, or powerful force? What's more common, right? This can be used for word usage. For example, if you say uh, powerful force versus strong force, what would be more appropriate to say or to use by the computer? You can look at it by looking at a big corpus and analyzing which one's more frequent. That's probably the more correct usage of the word. So for example, we have here the collocations of strong with many words, and then we count, the most frequent words that go with strong. Strong support. That's how strong is usually used. Powerful usually goes with powerful force. Okay. Now, so if we're thinking of, for example, we can ask questions. So in this same list, for example, we can filter, right? We can filter with bigrams. We can filter email or we can filter text and see what's more common. Now, for example, we can answer the following question: what is more appropriate to say, strong criticism or powerful criticism, right? And we go to our list of strong and powerful collocations, and we see that criticism here with strong is roughly in the middle, right? And it happens 13 times. But powerful criticism doesn't even show up, so it's less than 4 times. Therefore, most likely, the most the good usage would be to say somebody had strong support or or somebody had a strong criticism about something else, as opposed to say someone had a powerful criticism. Now, one might use different words for different effects, and that is totally fine. But in general terms, one can find word usage by looking at which words go with another one in a collocation. Now, we can look, for example, for what's the most common word with university, and that would be degree, right? So university degree. If we find an email that has the word university and not the word degree in it, well, probably it's okay. But if it has the word degree, it might be spam. There are so many usages of this kind of computations. We can look also for spam email that spam, and see what are the common bigrams, the common collocations, and see if those are the same of non-spam email, for example. Now, could we use the web to ask these questions? That is an open question for you. How would you determine the frequency of collocations using the World Wide Web? Think about that. We might mention it in future videos, but there are several tools there to do this. Now, some collocations consist of 2 words that co-occur but not consecutively. For example, the word knock and door. Okay? She knocked on his door. They knocked at the door. 100 women knocked on the Donaldson's door. A man knocked on the metal front door. Right? Clearly, knocked and door here are important, but they don't go together one after the other. They're not consecutive. But they do have they do occur together, right, to some extent, intuitively. Now, you knock on doors, you knock on wood, but you don't knock on cheese, right? So cheese and knock might not occur so much. So one thing that that we can use is, well, use a window around the word, right? So we know that knocked on door, so might happen like this. So let's use 4 grams or a window of 4 words to detect words that go together, collocations. Okay, so the collocation of knocked on, knocked this, knocked door, on this, on door, those are all collocations that we can detect in a window of 4. But then or in a window, yeah, in a window of 4. Now, if we go here in a window of 4, for example, 1, 2, 3, 4, we get knocked on the metal. But it's a metal front door. Here's the word. So how do we look at this? Well, one way of doing this is to say, okay, I'm going to look for the word knocked and the word door and see how far apart they are. Okay, and there are several ways to count how far apart they are, but one, for example, would be, okay, I get to the word knocked, and then how many words before that or after that is door? On his door. 3 times. It's 3 words ahead, or an offset of 3 words. If I am knocked, to find the word door, I have to offset 1, 2, 3 words as well. If I am here and say knocked, and then 1, 2, 3, 4, I have to offset 5 words. And if I am here, knocked, I would say on the Donaldson, apostrophe S, I'll count it as a different word, and then door. That's another 5, offset of 5. You can count Donaldson as one word, and that would be an offset of 4. That's up to the person doing the analysis, or the programmer of the analysis. So I can see what the mean of the offset, so roughly what's the average offset between knocked and door? It will be, well, I have 4 documents, so 1 over 4 times the offset of the first one, second one, third one, and fourth one, right? And that gives me an average of 4, right? So 4 might be something that I will be willing to account, right? And 4 will get me these sentences. A window of like 4 will give me these sentences. But I still need the bigger sentences. So the average is a very good place to start, right? But then we need to say, well, the mean is 4 plus or minus X number of words. And that's what I'm interested in finding out. For that, there's a measure called the variance, okay, which measures how much an individual offset varies from a given mean of anything. In this case, it will be mean offset of words. So if n is the number of times the 2 words co-occur, okay, so in this case, it was 4, and d sub I is the offset on, whatever sentence or whatever co-occurrence we're looking at, and d bar is the mean offset, the average offset. This, we have all the elements, so we will go for all the instances that we see the collocation. We'll see what's the distance of the given instance minus the average distance divided by basically how many collocations I have total, right? Minus 1. That'll give me the variance. Now, usually we take the square root of that, and that gives me the standard deviation, or sometimes sigma. So let's look at the sentences. She knocked on his door, they knocked at the door, so on and so forth. We can see that the mean, right, the average was 4. We established that in the previous slide. Oops, sorry. The average was 4.0, right? That's the mean, or mu sometimes. That's the mean. Now, what I'm going to do is the standard deviation. I'm going to use this formula here. I'm going to go for every one of the occurrences. What's the distance of the occurrence minus the average, divide it, and then do the division. So there's 4 sentences, so n minus 1 is 3. The first one, the offset is 3, right? So on this door, that's 3 words, minus the average, squared, plus, and so on and so forth. I do this for every one of the sentences. The last one, the distance is 5. The average, we know, is 4, squared, right? This will give me 1.15. So therefore, my distance, my window might be of 4 plus 1.15. So my distance might be of 5 words, right? That might be anywhere from 3 to 5 words. That will give me the window. Now, we can compute this for any given word, any given collocation, and we will get interesting results. So for example, I'm going to use the word strong, okay? And I will look at it with strong opposition, all the times that it occurs. We see that the average is around, strong opposition is about 1, okay, the distance for all the occurrences, right? So the mean is 1.15 and the standard deviation is 1. So anywhere window between 1 and 2. So strong opposition, they go together very closely together all the time. However, if we look at strong with support, strong support, they mainly go together, but there are times when they go separate, right? So with respect to support, so we have strong and then support, right? That's why these are negatives, because it's with respect to this word here. But so the mean is negative 1.45, so a little higher than this one, so they tend to occur slightly more separately, and the standard deviation is 1. And we can see in the graph that they do occur more separately. There's some that are even like 4 words apart. And then if we look at strong and the word for, so for strong advice, strong for the people, or strong support for a candidate, right? We see that strong usually occurs very clearly 2 to 3 words apart from 4. So the mean here is 1.112, but the standard deviation is 2.45. That is, or 2.15, that is a large standard deviation, right? It's a large standard deviation, meaning the words strong and for are widely spread out. So this is what these collocations and the distance between collocations can tell us. Now, we have the distance between collocations, we have all that. Now, a collocation, remember, we can define it as a set of words that go together, that tend to go together. So, now what we want to find out is whether these two words are indeed a collocation, meaning these two words go naturally together. So, strong and the word binder, they might not go together as well as, for example, strong support, right? Or strong for might not go together as well as strong opposition, right? So how can we measure that? Well, first we can formulate a hypothesis, and we will sort of be devil's advocate here. My hypothesis is going to be that the bigram that I'm looking at is not a collocation. That's my hypothesis. If I can contradict this, then it's a collocation. So if the probability of not being a collocation is very low, say about 5%, we will reject the proposition, right? So this is 0.05. All right, now, however, if the probability of this hypothesis is not so low, then I cannot say that the bigram is not a collocation, right? So that is, if I can find a probability of a very small probability that the bigram is not a collocation, that means that I'm pretty confident that it is a collocation. I'm probably 99.5% confidence, right? So this alpha here is just a coefficient that's a proxy for how confident I am rejecting this H0. So again, just to summarize, I am working as a devil's advocate. I will assume they're not a collocation, and I will try to say that the probability of this is extremely low. So the way this works in sort of like intuitive sense is that if two words have probabilities PW1 and PW2 of occurring, well, the two together will have the probabilities multiplied because I will assume they're independent, right? Now, a collocation should have a probability that is very different than this. It's not even close to this, right? Because this assumes that both probabilities are independent. Both words are independent, but when both words are dependent, this probability is going to be very different. That's the idea. Now, there's one statistical test called the t-test that is used to test how statistically significant, or what's the probability that I have to reject the hypothesis 0, that basically two means are the same. So remember here, we're looking for probabilities, and remember the one metric that we have to measure collocation so far is that average distance between the two words, right? Because it's an average, right? And we can measure whether that average distance is significantly different than some other distance or some standard distance. So this is a little formula that helps us, where it says this is the mean, right? The mean of the sample that I see. This will be the mean of the distributions if the words were not a collocation in the text. This is going to be the variance, right, of the sample, and this will be how many sentences basically I have with that collocation. So again, that's the formula for the t-test, and let's see. Let's use it. So look for, is new companies a collocation? Does new and companies occur together as if they're a thing together? Well, let's look at this. New happens 15,000 times in my corpus, and companies happens 4,000 times in my corpus. And the bigram, new companies, happens 8 times in my corpus. Also, I need to know there are 14 million words in my corpus. Okay, so this is the data that I have from my corpus. You can get all this data with automatically. Now the thing is that, is new companies a collocation, or is new and companies two very independent words that just happen to co-occur every now and then? So let's look at it. The probability of new is the probability of seeing new among all words is this number here, the times that new happens, divided by the times that I have a word in general. So new divided by all the words in the company, in the corpus. The same thing with companies and the same thing with the bigram. So let's look at this. The probability of new is this one. It's the number of times new occurs divided by the total number of words. Same for companies, same for new and companies together. So if the words are independent, not a collocation, I would have to multiply the probability of new times the probability of companies, which gives me basically 3.6 times 10 to the negative 7. So 7 zeros before the 3, 6 zeros before the 3. That I'm going to call mu. Now, if they are dependent, right, so probability of new companies, this will be 8 divided by this number, right? And that gives me 5.591 times 10 to the negative 7. Yeah. So, if the words are independent, these two probabilities should be similar by some statistical measure. That statistical measure is going to be T, the t-test. Okay? So we can plug in the numbers in the formula. We have x bar is this, mu is this, s square, we don't have it now, but we can assume if the probabilities are small, like these ones are, s square is approximately the probability times 1 minus the probability. That's similar to p of x, p of this thing, right? So let's plug in the numbers. We have x bar, mu, s square, which we established is the same as this probability, and n. Forget about this letter n right there, right? And we see that the coefficient here is 0.9999, right? This is a value that we can look up at a t-table, and you can look online any t-table, and this will give you that alpha, that confidence interval, that confidence coefficient. Okay, this gives us 60% or 70%, between 60 and 70% of confidence. That is not enough to say that new and companies are a collocation. They might be, they might not be. We simply cannot say for sure. By the same token, there are some words that you can compute that might very well happen to be a collocation. Sometimes words are not normally distributed, and you can use what's called a chi-square test, or likelihoods, which these are all approaches that we will learn later in the course. But again, they're basically statistical tests.